people collaborate with AI, that this has an impact on how people dehumanize and things like that. And that is actually possible, when you develop your own applications that you connect with ChatGPT, and then you observe what downstream consequences that has. So if, for example, people dehumanize or trust specific output more, or whatever you're interested in. So maybe to start, I want to show you some use cases. Actually, what I have done, or this is a little agenda of my of my talk. So I will show you some use cases, and then I will show you actually how the architecture looks like for these applications. The more simple architecture is actually only using JavaScript. For that one, we would need Qualtrics. That's why Shubin yesterday already said that it would be great if you have a Qualtrics account. Just for the simple fact that Qualtrics, when you develop these mobile apps that people, or these web applications that people interact with, you need to have them online anywhere. So you need to have an interface for people where they can actually interact with and that you can observe. So you can either do that by your own website, or you can just simply use Qualtrics, which is already there and which also allows provides other advantages, that you can ask questions, because Qualtrics, for those who don't know, Qualtrics is a survey platform where you can then actually ask questions afterwards, how people perceive the interaction and things like that. So yeah, that is the first part, how this app architecture looks like and how to implement that with JavaScript in Qualtrics actually. And then it becomes a little bit more complex with Python, because I will show you a small disadvantage that exists with JavaScript, and why it may make sense actually to have a so-called Python backend, so that the JavaScript is not directly interacting with the generative AI service that you're using, but that you have a backend, Python backend, that is actually in between. And then I try to give you a brief introduction into RAG, or the long term is retrieval augmented generation. So what kind of like the theory or the technical architecture behind such a system is, and also how to set it up for yourself, and what you could use it also for if you want to kind of like build such an application for others, that they actually interact with your RAG system. All right, but before we start with that, I just want to give you an overview of some use cases. So one use case is something that Shubin yesterday already introduced a bit. So it could be, for example, an interview bot. So Shubin has his program, own one, Mimi Talk, but you could also, for example, have an interview bot that you connect with Qualtrics. So you can kind of like create your own interview bot. So this is how it looks like. The preview in Qualtrics. So yeah, this is how the survey looks like. It's just a normal survey interface. A description. So this is nothing special. It's just the text, right, in the survey. You would need to kind of like provide a prolific ID, what you usually have in surveys. And then you have this interview bot. So it's loading the message, and I'm not sure if we have, because the assistant is speaking, but it's on my system here, so I think you cannot hear it. But it's actually reading out a question and asking you about it's about music and artists. So it asks you basically if you are okay to have an interview on musicians. And then you say, yeah, let's go. And then it would actually read out the next question. Unfortunately, we have been here in the condition where it's reading out the message. So you cannot read, or when it's speaking, so you cannot hear it because it's connected to the system. But with this research, we are actually investigating if the modality, so if the ChatGPT is talking to you or it's writing to you, has a different impact on how people actually interact in an interview. So if people are sharing more or less information, if the ChatGPT is talking versus writing. So this is the idea what we have here with this use case. Another use case can be that you have chatbot interventions. So there is, for example, one pretty popular paper that was published in Science that has shown that chats with ChatGPT can durably reduce beliefs in conspiracy theories. So what they also did is that they implemented or that they connected ChatGPT with Qualtrics, so that people interacted through Qualtrics with ChatGPT and had a chat about conspiracy theories. So I can like replicate it, this survey, and what I also try, or what I would manipulate here in this survey, for example, is I connected a reasoning model. So I try a little bit of a different model, what they have in comparison to the Science paper. And my question that I would like to investigate here, for example, is, are chatbots where you can see the reasoning, like with DeepSeek, when you can see these details of the reasoning, does that actually have a bigger impact on how much it reduces conspiracy beliefs in comparison to models where you cannot see the reasoning? So you can, for example, manipulate these things, and you can have these experiments where you randomly assign people to these conditions. So is there a conspiracy theory that you believe in and that you would like to have a chat about to reduce it? Anything that you would like to chat about?
9/11.
9/11.
That was
set up.
yeah.
The 9/11 attacks was set up by the US government. Okay, so now it's asking you, this is the logic in the survey, could you just share more information about it? So can you please describe it? And then it's, I mean, you don't need to provide a lot, but you can just say, I think that there are many facts that do not fit together, and it was a good explanation to, I don't know, attack other countries. So now it's generating a summary that is already done with an LLM. So here it's generating the summary. So in the background, it's calling the API now of whatever model you connect to the JavaScript. So here, this is the summary. So the 9/11 attacks were orchestrated by the US government to justify military actions against other countries. And then you would, in this survey, you would just provide an answer how much you actually think that this is, that you're confident in this statement, and then if this summary is actually accurate. And then you would start to have a chat with the chatbot. So here, this is just the explanation for that in the survey. And then it's starting to generate an answer based on the summary that was provided by the chatbot before. So here it's about 9/11, especially when so much is at stake, blah, 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 blah. So this is, I think, DeepSeek that I have connected here to this in the JavaScript. And then it's asking me some different things. What parts of officially story felt most unresolved to you? Maybe we can explore them specifically. Well, I don't know, but I don't know, just the entire situation was not clear to me or whatever. And then it's generating an answer based on what you have actually input into the system. And then you would have a chat about that. And this is actually what they did in the Science paper as well. And what you can do now, when you have this implemented, you could then, for example, change different, you can exchange the LLM that is working in the background to test if different LLMs work better than others. You can then also, what we talked about yesterday, you can change some settings with the LLM. That it's, for example, more emotional in the responses or more functional or things like that. Or, for example, what it just said, this is a reasoning model. So you could also display, for example, the reasoning process that is going on in the background. And is it more convincing when you see the reasoning of the model versus not? So in this condition, you would not see it. Mm-hmm.
Aren't you here then just limited by the ideology of whatever background foundational model are you using? This is basically what you get is the ideological answer of the model that you use. So if you're having here, you saw inputs into DeepSeek, that then turned out that if you now try, Winnie the Pooh theory or what happened at Tiananmen, what is exactly what will be written? Will be very much skewed, right?
For sure, yeah, depends on the model, and that would be, for example, something that you could also test with this technique. So you could, for example, test if DeepSeek is reducing conspiracy beliefs less than maybe an American model like ChatGPT, for example. Because now it's connected with DeepSeek, but you could also just connect any other model in the background, and then you could, for example, compare that. So the reason why I'm showing that is not because I think that this intervention works pretty well, but just to give you a use case, how you can, why it makes sense to actually have other people interact with generative AI and to see what potential consequences that has. I agree. So it depends here in this case definitely on the training data of the LLM, which might be actually an interesting question to investigate. So what is going on here? So this is the basic architecture that you would need to set up such a system. So what I said already is that you have the user, and the user is interacting with an interface. So you need to have just any option for the user to input text or language, the description, and in this case, we are using Qualtrics for the sake of simplicity, because it is a web interface that you can easily use and that offers JavaScript. That you can embed JavaScript in Qualtrics, a programming or coding language, actually. And then this Qualtrics script is calling any generative AI that you are working with in the background. So you can choose if you want to connect the API of OpenAI or Anthropic or DeepSeek, or yesterday we were working with the API of Google. So you got a Google Gemini API key. So you could connect actually any model that you want that is connected then to Qualtrics. So the user actually inputs a prompt to Qualtrics, and this one is then forwarded to the generative AI model in the background that creates the answer, as you know it from your own interaction when you use the ChatGPT interface, sending an answer. And the answer is then presented in Qualtrics to the user. Different things that you could, for example, investigate with this kind of like technique. So you could see if, for example, the modality of how the user is interacting with Qualtrics. So, for example, writing or talking to ChatGPT, if that has an impact on, I don't know, how much people are satisfied with the outcome, or if that has an impact on how much information they reveal in an interview or things like that. Or the input length, does that have an impact on how much people are satisfied with the behavior of the AI? You could also manipulate things more under the hood, so in the background. So in fact, how you adjust the system. You can adjust the temperature. So the higher the temperature, the more technical and the more consistent the output, the lower the temperature, the more creative, for example. Does that have an impact on how much people, I don't know, how productive a collaboration with AI is, for example? Then what we just discussed is you can actually check or compare different models here. You can check, for example, if DeepSeek is working better to reduce conspiracy theories in comparison to OpenAI, for example. Or when we stay in a marketing context, is one model working better to convince a potential customer than another one? And then also you can manipulate then on the outcome if what we saw before in the interview, what you couldn't hear, if actually the chatbot is talking to you, so has a voice, or you can only see the output as a text. That's also something that you could manipulate and then see if that has an impact on how much people are interacting with the chatbot, how much they like the interaction and things like that. We already talked about yesterday about the API. And that's what you need here in the background, where the JavaScript of Qualtrics is actually interacting with these generative AI models. It's doing that with an API. An API is actually kind of like a socket in the internet. So many web services are using APIs, very often also without you knowing it. So for example, when you're using Spotify is also using APIs in the background to actually reach out to their own service to get a song that it's played to you, but you don't see it actually, the API is used in the background. Another example is, for example, when you have a website and you have Google Maps embedded in the website, it's also connected with an API to the Google Maps services. And for that one, you need to kind of like identify with an API key. So that's what's going on in an API. So there are different kind of APIs. The one that we are using here is a so-called REST API. And there are different information sent in one API call. So for example, first of all, you have actually the location where you have the service. So the URL, similar when you go in your browser, you go to Amazon.com or wherever, you also type in the location of the website. And that is the same with an API. So you would actually tell in the code where the service is located. Then you would tell what method you want to use. So what we are doing most of the time when we are interacting with generative AI or using their API is that we have a so-called post request, so that we are posting something to a service that is creating data or creating content. And actually, you have different headers. I would say you could call it some meta information, like which output content you expect, so that it would be actually a JSON format. This is just a format how the data will look like. So it's not Excel or anything else, it would be JSON. And here's the API key, so the authorization that you are allowed to use the API. So that would be also sent in this request. And then there are some more optional query parameters. You would have a request body. So actually, what are you sending to the API? In our case, that is kind of like the input to Qualtrics. So the text that you are sending, like, I don't believe in 9/11 attacks, blah, 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 or the summary of this first interaction that you had. And that is then sent to the service. And then you get a response. And there are different response codes that you can get. You get the response body and also some other meta information. So that is kind of like the technical part of an API and what you send there and what you get back. Just that you have a little bit of an overview, because when we go into the kind of like development of such a system, that it may make sense that you know a little bit, how it looks like and where the main thing actually happens. The system or the service that I'm using to kind of like in this workshop is called Fireworks AI. And you can all, if you want, you can all go there to Fireworks AI. And I like the kind of like metaphor that Shubin used yesterday for some services. It's kind of like a dealership for models. So yesterday we had, I think it's called Poe, and that's kind of like the dealership for the end user, and Fireworks AI is a bit like the dealership for the developer. So where you have different models that you can connect to with your API. And so when I put that into my browser, I have a model library. So you have large language models, you have also image generation, you have speech to text, so different actually generative AI services. And you can see all the different models that they have. You also see the price for API, because that's why you should, what we said yesterday, you should not kind of like disclose your API key, because an API call usually costs some money. And here you see that you pay, for example, 90 cents for 1 million tokens. So a token is usually can be a word, or it's a small fraction of a word, and you pay 90 cents for 1 million of these fractions. We can then use, for example, here a model, the Llama one. I think that's from Facebook. And what you see here is also how the API call looks like. So in all the different services that you're using, and that would be also the same when you're on ChatGPT or OpenAI or Gemini or wherever, very often they have a documentation. So for developers, kind of like a description how their service works. And that is usually pretty helpful if you want to kind of like set up such a system, because the structure of an API call, or the syntax, can vary from service to service. Like the general structure is always the same, what I said, but the URL is a bit different, and sometimes you have some more information in the body that you can provide to a model that other models don't take, and then you would get a syntax error, because I don't know if, for example, ChatGPT's API has presence penalty, and if you would send that to the API, it wouldn't recognize it, you would get a syntax error. So it's always good to go to the documentation, because it gives you really how the API call should look like, what they are expecting. And there you can see actually the different information what we saw before. So this is kind of like a template for an API call. You would also need, what we said before, you would need to have an API key to access their API. And I think this is what makes sense now, that you go to actually Fireworks, get authorization, or kind of like a login for the service, so that you register there and get an API key for Fireworks AI, because then we can create an online or web-based application with a Fireworks model.
Can you use the API key from yesterday, or a different one now?
A different one now. So the one from yesterday is for Google services, and this one would be for Fireworks, actually. We could actually set up the same thing with Google, but I know the documentation of Fireworks a bit better than the Google one. So Yeah, and this way you can see also a different service and how it works outside of Google. For example.
Fireworks also uses a model like Llama or Gemini.
Yeah,
right?
so exactly. So what you have is in Fireworks, that you, I mean, here we have a Llama model.
Yeah.
So the 3.18 billion parameters. When you go on their model library, so they have 161 models actually, or 157. I don't know if that's whatever. So they have a lot of different models that you can actually choose from.
Mm-hmm.
And that is the advantage in comparison to only using Google. So it's a bit like the same when you go to like either Mercedes and buy a Mercedes, or you go to a car dealership where they have different brands, and then you can just choose from different brands as well.
But if I had a Llama API key, I could not use it with Fireworks.
No, it's different. Yeah, it's kind of like a service in between. Yeah.
Okay. Where do I get this API key?
So you can Fireworks AI, and then you would use you would need to. So I already have an account. So you would set up an account, sign in, log in with Google.
And then once we get API,
Yeah.
we go to model library or what?
When you have the API key, you save it, that you can use it later. And then I will show you what to do with it afterwards.
This is for free?
It is for free, yeah. So you have, that's why I'm using it. You have like $1 that you can use for free. Yeah, exactly. Yeah. And $1 is already, quite a lot to do, quite a lot of calls. Yeah. Good. So does it work for everyone? You get the API key and perfect. Before we go into the actually development of our own app, I just want to give a brief background of what a website is and what we would need from the Qualtrics website. As I said, we need a website as an interface for people to interact with ChatGPT or with any model that we have in the background. So a website consists of 3 different parts, and we had that already yesterday when Shubin was developing this Pokemon app. So you were writing HTML, CSS, and JS for JavaScript and put it all into one HTML script. So a website has this HTML part, which is basically the content of a website. So it's plain, or not plain, but it's just mainly text. When you remember about the early days of the internet, this was purely HTML. So you can make some headlines bold and maybe red and whatever, but you don't have a nice design of the website and you don't have any interactivity. So the appearance of the website comes then from the CSS script, which is design. It gives the website a design and a structure and so on. But what both of these languages have in common is that they are only markup languages, so they are not like coding language or programming languages. And that is what JavaScript is, and that's why we need actually the JavaScript from a website to interact with our generative AI in the background. All right. So you have that already. So the Fireworks AI API key. And for those of you who don't have a Qualtrics account, it would be also good if you have a Qualtrics account if you want to follow along the development of such an interface. Very often, I think universities provide free access to Qualtrics when you sign in with your university email. If not, you can also create kind of like a trial account for Qualtrics, and you can also use that for embedding JavaScript. You have some limitations in terms of the different questions to embed or to include in a survey, but this is not the focus of our topic today. So in fact, that should work too. And then the next thing that I would like you to install is Cursor AI. And that is the tool, very helpful tool that we are working with today to kind of like to develop the code, because I'm not a technician either. I have not a lot of coding experience actually, but you can set up all these things just with the AI support that you have included in Cursor AI. It's a bit similar to the Lovable that we had yesterday, but Lovable is more focused on the front end, so similar like the web development. And Cursor AI is better, for example, for Python and some backend development. There are also other services like Windsurf AI, and there are many other competitors trying to get into this coding landscape or coding industry. Many startups, but the one that I'm using and that I had the best experience with is Cursor AI. So please go to Cursor AI and download a Cursor AI, and you would also need to have an account for Cursor AI. You can also use Cursor AI for free. You have a limited number of requests that you can send to the AI that is embedded in Cursor AI. When you are becoming a heavy user, then at some point you need to pay for it. Then you have no limitation on how many requests you can send. But are there any questions that I can answer in the meanwhile, or anything from the chat that?
I answered already.
Okay, perfect. Thanks. Is it working? Yeah, it's done. Great. Okay. So yeah, you can open Cursor AI if you want, and then I will just set up a folder here as. And I think you should have kind of like a screen similar like that one. So quite clear. So what you have, so what Cursor AI is, it's a so-called IDE, which stands for Integrated Development Environment, I think. So you can, it's kind of like a software that facilitates the development of different scripts, whether that is a JavaScript or a Python script. There are other ones. A popular one is Visual Code Studio from Microsoft, for example. Cursor AI is one IDE that has an AI integrated that helps you a lot with the development actually of your code. Because as I said, I used to, I use R code sometimes to do my analysis, but I'm definitely not an expert in that. And I had some basic ideas of Python, but definitely not a lot. And I think these tools like Windsurf AI or Cursor AI, they really allow you with their AI that you have here on the left-hand side, if you don't have it yet, you can just click Control and L, and then usually the AI should pop up on the right side. Is that correct? Oh, perfect. And this one is actually connected to different LLMs. And you can ask them different questions about coding. You can here select the different models that you want to have. What is usually by default selected is auto-select, but you can then, when you deselect that, you can select the different models that you want to have as kind of like supporter for your code development. And there you can see here, for example, the latest Claude models that are the most advanced ones, also very good in coding. Then you have the Gemini and whatever. Some are better and some are a bit worse in coding, actually. Because Coursera AI also wants to earn money, they actually make some of these models only accessible for pro users, and sometimes even as a pro user, you have to pay for some kind of like, I would say, premium requests, additional money. So it's kind of like 5 cents per request. And many people were complaining about that because now there are more and more hidden costs actually in these IDEs. And so what I read is that some people are changing from Coursera AI to Windsurf AI. I was a Windsurf AI user, but at some point it got pretty slow. And that's why I changed to Coursera AI, but it's a bit similar with like all these different AI models. Then sometimes ChatGPT is better, then Gemini comes out with another model, and this one is better. And it's a bit like the same with these kind of like intelligent IDEs. So usually auto-select is fine for us. What you can also do is you can actually give different permissions to the AI. So the most autonomous one is obviously this agent. So it would create automatically the code, and you don't need to do that much actually anymore. It might be good sometimes, maybe even for the beginning, but I usually use the ask function where it's also providing code to me, but I need to accept it. So it gives me a bit more control over what I actually implement into my script then eventually. And that's why I personally prefer this ask option. And then when this is working for you, we can just go actually into the development of our JavaScript, and you can just prompt it with what you want to have. So of course it makes sense to be as specific as possible, similar with when you are just using ChatGPT for your normal usage. So here, what we would do, for example, please create me a JavaScript code for Qualtrics that provides a text box for the user and sends this text box or text input to the Fireworks AI API. And then what always makes sense is to give the LLM some context. And that's what I meant before with the documentary, where you have like the instructions from the service, because sometimes it looks a little bit different. And then the LLM that you have embedded here in the program doesn't know all the details about the API call. So maybe the URL or a slash is not in there. So it always helps when you copy and paste. So it's gone here in the image, so you cannot really see this here, but it's here in the context window for this chat, what I've just copy and pasted here from the prompt. And then also to copy and paste, for example, if we want to use this Llama 3.1 8 billion instruct model, to take here, you can select actually the different languages, coding languages that you want to use. You want to have Java, kind of like the template, the example of how the call looks like. So you would give that also as context to the request to the to the AI. And then you would just click send, and then it's generating here an answer for you and the code.
Why do we go now via Fireworks AI? Why don't we connect Qualtrics directly with a model like Gemini or?
Yeah, we could do that as well. It would be the same. So in fact, we would just tell the AI here now, hey, please connect, please give me a script. So what I said here in the prompt, please create me a JavaScript code for query that provides a text box that the person can send to the Fireworks AI API. If you want to use, for example, Google Gemini, you would just replace it and say that sends the input to the Google Gemini API. It would be actually the same, yeah. And
why Fireworks? Why this intermediate step?
Well, it's not an intermediate step because, in fact, it's doing exactly the same. You're using a model directly, actually, just from Fireworks. So it's not that you have a step in between. It's like just that Fireworks provides the model. I'm using Fireworks because there you can easier replace the model that you're using. When you're using Google, you only have the Google models. When you're using Fireworks, you can just in the API call replace the model that you want to use. So it gives you a bit more flexibility, and that's basically the only reason. And for me now, I'm more used to the kind of like how the Fireworks API looks like than the Google one and the documentary. So that's why I would stick with it. But you can also try, actually, if you want to, you can also try to do the same with Google Gemini. You can just change this prompt and tell it, please connect it to the Google Gemini API. What would make sense is to look on Google Gemini for the documentary, that you give what I said, a little bit of context. I mean, the Google Gemini API is a pretty popular one, so it might be even the case that this is even in the training data of the LLM, so it really knows how it looks like. But I think it always makes sense to give this really the instructions from the service itself. Yeah. So this is the output. So in fact, it tells me, okay, I help you create that. It's here an HTML script that we would put then into the JavaScript box in Qualtrics. I will show you how that looks like. And here's also an explanation. So this code creates a simple web interface, a text input field, a send button, then you can send it, and then a response area where the AI answer is actually displayed, some error handling, some basic styling that it looks as a decent interface that you're using. Yeah, you can save it. What you would need to do is then at some point that you need to replace in the script your real API key that you got from the Fireworks API. Here, this placeholder needs to be replaced by your own API key. Okay, and then you would click apply. That doesn't work. So what you need to do is you would need to create here on the left-hand side. I hope that you can see it. You need to create a new script that you can then use, that you can call, for example, Qualtrics JS for JavaScript. If it would be a Python script, it would be py. So it's a Qualtrics script. And then you can here click apply to Qualtrics JS. And then it's going in there. And then you can accept the file. What you also have is here, because I'm here working in this class project, you can see this script that was just created here. So you see everything then also really in your file explorer. And then you would take it and then, oops, I need to replace the API key. So, and here, this is where your API key would go. So it was also the explanation here, I think. Or you could also just give it to the AI and it would replace it. I mean, as Shubin also said yesterday, usually you would keep the API keys for yourself and you would not reveal them, but just for the for the presentation, I'm using the API key that I have here for Fireworks. The problem is if you don't have a limitation on the API, especially for companies that have like a huge amount of how to say, like access to APIs that are not limited. Usually as a single user, you cannot just call an API for many thousands of euros. But if you would have an API key from a company that has kind of like unlimited ChatGPT usage, it could go up to millions if you would just like send over and over to the API. And that's why revealing the API key can be quite dangerous. Usually it's limited so that this cannot happen to you, but for sake of security, usually you should not reveal this API key. And then you can also just say, please replace the API, or you can just say, here is my API key. And then it would usually go and replace it here in the script for you. So now, and then you need to accept it. So it has replaced here. This is now shown as red, a bit like in Word, where you see what would change, and then you need to accept it. And then let's see if that works. So you would copy and paste this JavaScript. And then you would go to Qualtrics. Qualtrics login. Yeah. And we could do a new project. So you would create a new project. Just a survey from scratch, that's completely fine. Get started, and then you can call it whatever you want. I mean, class project Oslo, for example. This is the default screen of Qualtrics. So a survey software, basically. So that's what it's mainly used for. You can add different questions here. This is like a typical multiple choice question. And there are many more questions that you can add, whether that is slider, open text fields and whatever. But we are not interested actually in how to create a Qualtrics survey, but how to connect Qualtrics with a generative AI. So what you usually use as you do, because you don't need to have here these answer options, the most plain question would be text and graphic. And then when you click on it, here on this question, so it needs to be kind of like highlighted, then you can click on JavaScript. And this is just how the empty JavaScript looks like in Qualtrics. And then you can just copy and paste what you took from the cursor AI. You can just copy and paste it here into the JavaScript from Qualtrics, and then you save it. Okay, and that is not working. So then if I have error, similar like yesterday, I would just go back to the AI and tell it, hey, I have a problem, please solve it for me. So I'm in Qualtrics directly where I want to embed the JavaScript, and I get this error. So, and then it's understanding, because it didn't understand that we are directly working in Qualtrics, but it thought we would keep it kind of like as a separated HTML script outside of Qualtrics. So now it knows, oh, you're working directly in Qualtrics. So it has updated the script. And then what you would do is you just click here on apply to Qualtrics JavaScript, and then it's doing all the changes here and what would be deleted. And then you click on accept the file. And then let's try again. You would just copy and paste it and then go back here and save. Oh, it's weird. Okay, so I made the changes. Let's see. Um,
Can you show us again the embedding into Qualtrics?
yeah,
It was a bit fast because
sorry, yeah.
it was a PDF, so we had to type
Yeah.
in.
So you would be on Qualtrics, and then do you have already a new survey set up? Yeah. So then you have a question here. And then when you highlight the question, you would click here on the left-hand side in the navigation, you would click JavaScript. Yeah.
So it would be a survey.
Yeah, exactly. It's a survey. And then you click on JavaScript, and then you would,
Yeah, where is the JavaScript?
it's here on the left-hand side. When you highlight a question, you click on just a question.
Mhm.
It's working.
It must be open.
Yeah, well, let me just see.
Of course. Does
Yeah.
it have to be text entry or?
When you scroll down, you can, so you can use text and graph. Set it up. It's a graphic. Yeah. And then when you scroll down on the left-hand side, there is JavaScript. And then you have exactly, then you have this window. When I click on JavaScript, it should be there. Okay, so let's see. So, I mean, I had some trouble now with, usually it's working better, but it did not really provide the code that is working. So I just told it again that I'm working in Qualtrics and that I don't need anything else. So I hope that it's working now. Otherwise,
Somebody in the chat say you might wish to use the responded code in conversation.
usually that is implemented here into the main JavaScript. But I can also, what I can do, let me check. I will do just another model.
I could copy it, but I don't know if
Could you save?
I would save it. Yes, yeah.
For you, it's working.
Yeah.
Okay, yeah, my one just gave me bad code. I don't know why. And if you try, actually, if you click on preview, I should have the option to interact with the chatbot now. Do you see a text box input?
Type your message here.
Yeah, type in, and then there should be a submit button.
Yes, I did that.
And when you just submit it, it should send your message to the Llama model of the Fireworks API.
Then it says error, there was an error processing your request. Maybe my code is also not.
Have you embedded your API key? Okay.
Maybe also the JavaScript code is
yeah, it's when you exactly try to kind of like interact with the AI from Cursor AI and see if it can help you with figuring out what's going on.
Yeah.
Because usually it's we'll just try again. What I did, I try another model here, and maybe this one is more intelligent to figure out the correct code. So now it gave me another code. Here, it doesn't have the API key yet, so I would need to kind of like replace my API key. So it's replacing that one. Now I hope that this script would work. So I go to JavaScript again, I paste it in. Okay, now it's saving it. And now I can see if in the preview, if it's actually working and interacting with the Fireworks API. So here it's saying, so this is the text box that was created, and then I can just interact with it. Hey, how are you doing? Send to AI. Okay, and I also get an error. Okay, so this is kind of like the proposal that the AI makes to change in the code, that this might be the problem why it didn't work. So I accept it and then just try again. Okay, it's giving me more. It might be a problem here also with the network in in BI. I don't know. Does it work for anyone?
Also,
Does it
troubleshooting.
the same problem?
No, a different one.
Different one.
It seems it's a cross policy, like, yeah.
Because sometimes it depends on the network that you're in, that it blocks these some API calls. Depends on the network.
You know, I have an issue of not being able to.
From the right side.
It's
Um,
kind of
mhm.
frozen completely.
So it's a technical issue with the.
This is after I have provided.
So you can type in there. No. And then you can type in, and then it should continue. You can type in what you're interested in, what it should create. Yeah, there is.
So that once it went in, then I got it.
Yeah, then you can transfer this code into a script.
Yes.
Mm.
So it did this, and then.
Okay.
There were 2 points in the relationship. After this.
Now, scroll up. To be another folder where you would like to have the project in. Oh yeah, you can just copy it right from there.
Yes, but we'll see. So this was my
You just take out everything.
2 scripts.
It's one script, but this is just part of.
You start inside.
So you replace everything. You click there, Control A, yeah, and then you copy and paste it. Yeah, and then you save. And then when you click on preview, yeah, you can potentially interact with it, but there were some issues that we were. So at least you see the window, and then when you type in something, yeah, and then you scroll down, you have the buttons. Yeah, so for you it's working. Yeah, perfect.
It could be firewall.
Sorry?
Then it could be the firewall.
Yeah, it could be the firewall actually, that sometimes it's blocking it. So there are some people for who it's working, right?
Yeah, but nobody really answer. But yeah, I think it is.
At least, yeah, for you it's working. So yeah.
The firework, yeah.
Yeah.
Because it's not security. It's not secure to have Java with your API, right?
Exactly. So that might be a problem then with the security by the network. Yeah. So I would say maybe we take a break and I try to figure out what's going on here, and then yeah, and then we continue with the plan. Yeah. Okay, great.
Let's take a break, and we will continue at 11.
Yeah, sounds good.
Oh, it's to maybe 10:50. Okay, 10:50.
Try.
No.
All right. Yeah, welcome back. So I used the break to actually figure out, I mean, not what was going on, but to figure out a working version. Are there any questions before that I can help with already? Okay, so I don't know what happened. So what I did, I changed the network here. Maybe it was restricted by the network here in the school. So I connected just with my mobile phone data, and that one, maybe that helped. But then also I just set up a completely new script and started from scratch. So I told it again, please create me a JavaScript that I can directly use in Qualtrics. I think I need to share this. No, the screen is shared, right? Yeah. Into Qualtrics, and I want that people have a text input in Qualtrics, and then this text input is sent to the Fireworks API. And then I was just copy and pasting kind of like the instructions from the Fireworks API, how that looks like. So, and then it created me this JavaScript that I just accepted. And then there was a problem because this first one, well, first, there was no API key in there, so I told it what my API key is. It replaced the API key here in the script. And then I copy and pasted it into what we did before, into the Qualtrics. And then when I tried it, I saw that there is no text box. So I told it, okay, I don't have the text box input. And then it told me, okay, if you don't already have the text box text input field, I modify the script, and then it modified the script to create a text box for me. And so then I ended up with this script here on the left-hand side, and that I just copy and paste. I copy it, and then I'm here in this interface of Qualtrics again. I highlight the question, I go to JavaScript, and I copy and paste it in there. So I basically mark everything and replace it and save it. So, and now when I click on preview, I have my input here. This one is just from the question, from the standard question. So if you don't want to have that, you can just like delete it or click space, then it's not there anymore. But here it's still in the preview. So then I would just say, hi, hey, and send it to the AI. It's processing, and there you can see that it's working now. So how is it going? Is there something in your mind that you'd like to check about, blah, blah, blah. So now it's working. And then I can further like elaborate. I could, I don't know, use it, for example, what we said before, that or what I've shown you before, to use it, for example, to talk about conspiracy theories and things like that. But this is kind of like the basic functionality, the basic technical arrangement that you need to have if you want that to actually connect Qualtrics with generative AI. And then what you can do with Qualtrics, obviously, what you just do with any other survey, you can publish it. You have an URL that you can then send to participants, and then they could use this service and can or use the generative AI that you have connected to Qualtrics, actually. All right. Can I help anyone with these steps or any questions about that? Okay. So here's the explanation in the slides where you would embed it. You need to add your API key, and then yeah, it would actually work. What makes sense when you're developing, this is just, we don't have to do it. It's kind of like optional, but when you are developing code, it makes sense to actually connect to GitHub. Yesterday you were using GitHub and the content that Shubin was providing there. But when you want to use it for your own, that also makes sense if you want to kind of like track the process of your code. Because the problem sometimes when you're developing code, or when you're developing, and you change something in the code, suddenly it's not working anymore. And then how can I get back? And so like you can do Control Z and whatever, but it's not perfect. So with GitHub, it's tracking the different processes of the code. So you can also go back to a previous stage, and that's definitely the advantage. Because you don't start with the final code. You would just start with kind of like the basic things, and then you add stuff and stuff and stuff. And then at some point you may have issues, and then you can go back to the working version. And that's why it may make sense to connect to GitHub. If you want to do that, you already have your account, and then you can create a new repository. And give it a name. For example, I mean, when you're on GitHub and you log in and you create a new repository, you can then connect it, and then you can push your code to GitHub, that you can track that and the development. But this is more like optional. If you continue with elaborating your code, and if you want to get it to a stage where you, for example, add more functionalities that you can work, that you can talk to the AI, or that the AI is talking to you, and things like that, then I would definitely recommend you to set up everything that you have it connected to GitHub, and then you can track the progress of your code. Something that we haven't talked about yet is actually different roles that you have in an LLM conversation. So first of all, you have, of course, the user, which is you, who is writing a prompt to the generative AI, whether that is an LLM or its image. And then you have the assistant output. So this is the output that the generative AI is creating. But a third layer in the interaction with generative AI is a so-called system prompt. So when that tells the generative AI actually how to behave. So you would tell it, be, for example, a friendly supporter, or talk, for example, what we had before with these conspiracy theories, talk with the person about conspiracy theories, don't be judgmental, and just be focused on arguments, for example. So this is kind of like the instructions that you would give to the generative AI. And that's also what you can do in an API call. So you can also in the API call provide a system prompt. So what you would do, for example, now in Cursor, if you want to change the behavior of the LLM that we are talking to, you would just give to the AI in Cursor here the prompt, add a system prompt that tells the LLM to answer, for example, in Shakespeare language. I would go here again to my input field for the Cursor AI, and I just pasted it here. What I don't like now is that they put it in as an image, so you cannot see actually the prompt, but this is here in the text field, or I can just write it in here actually. Please tell the what did I have? Or add a system prompt to that tells the LLM to only use or to only answer in Shakespeare language. So, and then it's creating or updating the script. You can click apply, and then here it's here where you see the green part. This was added now. And here you see actually in the script this API call. So what we saw before, where I've shown you that on the kind of like in the documentary of fireworks. This is the core of the API or of the script, actually, what's going on. So it's calling here this URL. Here is my authorization, so my API key. It tells the system how many tokens it should create maximally. And these are all adjustments that you can change. So you can then tell the system, for example, if you want to have shorter answers, you would just reduce here the maximum tokens. Or what we had before, now it's set to 0.6, that's temperature. If you would put it to 0.1, it would be much more creative, and the answers that you get are less consistent. When you increase it to 1.0, for example, you would have more consistent answers in the system. And then what we just added is kind of like this instruction, this here, what it says, role is the system. So it's kind of like the system prompt. And the content is you must respond only in Shakespeare English, blah, blah, blah. And it's telling actually the system in the prompt that is sending to the API, in the information that are sent to the API, how the system should behave. Mm-hmm.
Where is that apply button? Where did you click to apply?
So
Why do I see only one side and not?
so you have to add a script actually on the left-hand side. I can show you in a minute. Yeah. But we can just accept it, and then we would have this part here in the script. We copy and paste it, and then we go over again to the JavaScript, save it. And then it's answering in Shakespeare language. So good morrow. So I don't understand it anymore, actually. But yeah, it's answering in Shakespeare language. And you can tell it actually whatever you want. So, and then you can see if that has different impacts on, yeah, whatever you want to measure, whatever you want to manipulate in experiments, for example. And the good thing is that you have it in Qualtrics and you have access to Qualtrics so you can observe the interface. So I'll let you try that, and I will just figure out here what that I can help you. So what you should do is you should, do you have a folder where you would like to work in for this project, like any folder on the desktop or whatever? Yeah. So just, so let's see, for example, wherever you want, documents, click this. You need to create a new folder. And then you call it whatever you want. Okay. Then we can go back actually to the cursor. And then we need to open this open folder. This is the folder that you can it's that one. And then what we need to do is let's a little bit. This the left one, very left one, fire.
It's like a script.
Yeah, exactly.
Like a script in R.
Yeah, exactly. And we call it, for example, Qualtrics.js. Or JavaScript. Yeah. And then when we go on the left, on the right hand side, and you scroll up, then you have your answer.
That was the problem.
Okay.
I don't know how
But
to
if you would
scroll up with it.
start again, and
You
then
just try to scroll up again.
your chat is not there anymore. But if you would, so the script that you created kind of disappeared, but if you would start again. Okay, and then the one, yeah, click on this one. See your chat. But yeah, so if you would do the same thing again, create a new script, and then you should have the apply button on the right hand side. So, and then would all the answers that you get from the AI on the right hand side, you would transfer to the main script, and then this main script you can then transfer to Qualtrics. Yeah.
Thank you.
There was a question. So as the responses from the AI may be different across participants, will poetry save the AI response interaction somewhere?
Yeah, so that would be the next part. So definitely the answers are different because I mean LLMs are probabilistic and not deterministic. So now if I just send the same thing again, I may get another answer. Yeah, so it's a bit different, the answer, and everyone, I mean, it's not predictable. It's more predictable actually, but not completely predictable if you increase this temperature. Then as I said before, the answers are more consistent actually. So this is how you can change the behavior of the LLM that the person are interacting with. So you would just change the system prompt. And the question that we had before, if the question or the interaction is saved, that's not automatically the case. So we need to add that. So here's what I just did with the system prompt. So you tell the AI, okay, add a system prompt that tells the LLM to answer in Shakespeare language, and then you would get this output. The thing with the API calls, and that's a bit different in comparison to how you know the interaction with ChatGPT, for example, when you're just using it. Every API call is kind of like an individual call. So when you send another message, for example, so you would say like, can you please create me a plan what to do in Oslo for this weekend? And then you continue the chat, and then you would say, hey, can you go back to what you proposed before? The system, so because as I said, every API call is individual, it would not be aware of what it did before. That's a bit different in how you are used to ChatGPT because you're in this window and it's aware of the context. And that's why you need actually to create a conversation history for the LLM that it's kind of like context aware, that it's aware of this of the communication that happened before, that not every call that you send to the chatbot is kind of like an individual call. And that also allows you then to save the complete interaction in Qualtrics in an embedded data field that I will show you later, which would allow you to do analysis. What we did yesterday, the text analysis part that Shubin has shown, you could do that with the conversation that you track between participants and ChatGPT, for example. And then you can see, for example, if people who have using a specific language are interacting better, or if you have a collaboration, for example, have a better collaboration with ChatGPT on the language that they're using, so you can use the language, the conversation to do analysis. So, but to save this history, you would need to embed it in this script, and to embed it in the script, you go back to Cursor AI, and you tell the AI in Cursor on the right-hand side what you need. So I have prepared this prompt here already. I have this working script, but I want that the conversation history is stored so that the LLM is aware of previous messages. And then what I'm also telling, please save the conversation in an embedded data field conversation history. So this one is important, this embedded data field. Sorry. How is the screen?
You just need to share your screen there in the meeting.
I'm sharing already, no? Wasn't I sharing?
Now it's sharing. Yeah, now it's good.
Okay, sorry. So it wasn't sharing before, so yeah. So okay. But the Shakespeare part was shared on the screen, so you could follow that. Okay, good. So now I would tell the AI, I have this working script, but I want that the conversation history is stored so that the LLM is aware of the previous messages. And then also please save the conversation in an embedded data field conversation history, because that is then relevant for my own analysis. I want that the conversation is stored anywhere, and Qualtrics is doing that either in the questions or in an embedded data field. So I would just tell this to the AI in Cursor AI, and so then it's creating or updating the script that maintains the conversation history and stores it in an embedded data field. So here it would create the code on the right-hand side. And when it's done, then I get here on the top of the box apply to this Qualtrics JavaScript. So I just apply that. And this is actually what it's doing here. So it's creating this conversation history, and it's putting that conversation history in the prompt that it's sending into the API call, actually to the system. So I accept it. So what we also need, so now it would work for the API calls, but it would not yet work to save the conversation in Qualtrics. To do that, I need an embedded data field that is actually called conversation history, because that's what the script is doing. So the entire conversation history is stored in an embedded data field called conversation history. So to do that, I would go in Qualtrics in survey flow, and there I can add an embedded data field that I need to give exactly the same name that you also have in the script. So it was, and be aware of the letter, like it's case sensitive. So if it's a capital letter or what is the opposite or the opposite of that, it must be exactly the same. So not conversion history, then it would not work, conversation history. So in fact, exactly the same that it has in the script. So it might be even safer to copy and paste it, that you have exactly the same here in the embedded data field. I need to also copy and paste this script here into my JavaScript again. You see it's getting longer and longer because it's adding like history and stuff like that. You save it, and then you would click on preview. And it's still, because that's what we told it to behave like Shakespeare. So it's still answering in Shakespeare language. And also and that's sometimes what I don't really like when I'm using Cursor AI, it's not always strictly following what I tell it to do. So here, for example, it also created a conversation display area to show the ongoing chat. So it also changed the interface a little bit. So it implemented additional changes. Because it's an LLM thinking what you may want to have, but sometimes you don't want to have it. And it makes it just more complex. So in this case, it's fine and it's working, but sometimes you need to be aware and you really need to tell it only do what I tell you what I want to have in the script and don't add any other stuff, right? So, but if we would continue the conversation, then you would actually see it. And it's here in the, you have all the history here. And then you can talk to Shakespeare. You could go on and do whatever you want, yeah. So, and then usually what would happen, let's see if it's working. So now I kind of like finished the survey. And I hope that it works, because then when you go to data and I export the data, I need to have the values. I prefer CSV because that's the best format to analyze it, for example, with R. I hope that, yeah. So here, in fact, we have the entire communication with it. So let me just show you a bit better. So this is how it looks like, and it's also like it represents, so it's JSON format. So this is the format how the API is answering. And you see here, first of all, the system prompt. So the role is system, and then the content is what you have in the script. So you must respond only in Shakespeare language, blah, blah, blah. And then you have the role user, which is you as a user or any Qualtrics participant, anyone who you would share the survey with. And what we were talking with, we said like, hey there. And then the assistant said like, good morrow unto thee, fair sir, blah, blah, blah. And then we said, how are you doing? And then the next answer was, though ask it after mine own estate. And if you would continue, it would just put all this conversation here into this embedded text field, which you have then in your data output. And then you can use it, for example, for doing text analysis. All right. So this is how this works with the conversation history. Sometimes, from my own experience, it's not always working with the, or it's not, sometimes you need to prompt the AI multiple times or to kind of like go back and forth a little bit with the error, because it's not always working that smoothly that it's putting it automatically in the embedded data. Sometimes it stays empty, or because the AI thinks I want to have a specific formatting that doesn't work, for example, with Qualtrics, that I need to tell it, hey, just put the plain text in there in this JSON format, and then sometimes it works. But when you set up such a solution with generative AI and Qualtrics, you really need to double check if it's really going in there. So yeah, you need to sometimes troubleshoot a little bit. Yeah, but I'm happy that it worked now, and that you can see how it looks like when the entire conversation is then actually stored, yeah, in the output of the survey. Yeah, here's the explanation for that and how it looks like. One thing, but I would not go into much detail about it because it's getting a bit too complex, I think. But the problem that you have with calling the API directly with the JavaScript is that it's not entirely secure. So what you can see here is for some tech people who may know what is going on in the background of a website, they may figure out your API key. So you can go on inspect and you can inspect what's actually going on in the network. And here you can see, I was looking for that. So you can actually see in the output, and that would be also the same for any participant in Qualtrics, anyone who would use your system. They could, if they know where, and it's not too difficult when you have some technological knowledge, in the headers, because that is this kind of like metadata that is sent to the API, and where you have your authentication, you have your API key, which is kind of like this risk that other people are using it. They can like, yeah, use your money that you have on your API, or they can just block it. If it's like another researcher who don't want that you make progress on your research, they just like, yeah, like use your API like multiple times, and then you cannot use it anymore. So that's why it's not perfect to directly call the API from the JavaScript, but I also do it myself. So because it's the easier solution. And usually Qualtrics participants, if you sample people from Prolific, for example, or from mTurk, usually they don't have any interest into going into like, or they don't know it and they have no interest in actually to figuring out your API key. But just that you know, it's not perfect. And that's why for the best solution, you would actually code a Python backend. So what is going on there is that you would have a step in between. So the JavaScript that you have in Qualtrics would call the the Python script, which is a backend on your own server or on a server that you just use. So you could use, for example, from Microsoft, or there are other services. And then this script in the background, so that the user does not have direct access to, is then calling the AI. And here the API key is actually embedded so that the user here on this side doesn't have access to that. So, and that's what is the cleaner and the best solution. But it's also getting more complex because you would need a JavaScript here on the left-hand side in Qualtrics that is actually calling your Python backend. That is in turn calling the generative AI, and you have one step in between. So a little bit more complexity to handle. Yeah, I think I would skip this part because it gets too complex, but in the slides you have an explanation how to actually install Python on your system. What is important when you do that, you need to make sure that Python exe becomes part of the path environment, that it has really the opportunity to interact with your Windows or Apple system. I'm not sure actually how it's called in Apple, but because I'm a Windows user, but that you need to make sure that Python can really interact with your system. And then you would, set it up. And what you can also add in Cursor AI, but also in other IDEs, like what we said before, Visual Code Studio and so on, you have some extensions. So you have also, for example, an extension for Python, which makes sense to have because it recognizes syntax errors, for example. So it's better to use these extensions. And there are other extensions, for example, for GitHub, that you can easier push your code to GitHub and so on. So these are all things that you can, it's like an app store in this IDE that you can use these different apps that facilitate actually working in this IDE. Just that you have heard about it. You would need to install different things actually in this IDE to work with Python, but as I said, it gets probably a bit too complicated now, but it's in the slides. So if you want to test it out yourself, you have all the information what you need to actually install if you want to use a Python backend script actually. So I would just go back, for example, then here to the Cursor AI, tell, hey, I have this script that works perfectly. It calls the Fireworks AI API with the JavaScript directly from Qualtrics. Can you please transform this JavaScript into a Python script that I will use as a backend? The script should operate between Qualtrics JavaScript that calls the Python script, which in turn calls the API and forwards that answer back to the JavaScript in Qualtrics. So just the architecture that I've explained to you before. Then it's doing that. You need to install these things, and then it's running locally. And then you could actually test it on your computer if it's working. The thing is, so this is how it would look like. So you could call it from your own computer, hello, how are you? And then it would give you an answer. The thing is, if you want that Qualtrics is calling the script, because at the moment it's only on your own computer, so it cannot call it. You need to have it online anywhere. So you need to host it in a service. They are different, or to deploy it. So there are different services that you can use. There are some easier options, and I think they are definitely decent to use for researchers. One is called Heroku that I made very good experience with. It's quite easy to use. It's directly connected to GitHub. So automatically all changes that you make in your script and that you then upload to GitHub is also automatically changed then in Heroku. You need to pay a little bit for that. It's not super expensive, but it costs some money. So you can use for free. You can also test Render. Render is also a software, a service, a website where you can host your application. You can install it, and then it gives you a URL, so a website basically, not a website, but like how you would access a website with a URL. So Amazon.com, it would give you the same logic. So a URL as well. So this is kind of like the steps what you would need to do in render. It's all explained in the slides. You can use the free account here. You need to add also the kind of like securities or the secrets to render, because then everything is installed basically on render. And then it would deploy it. And if it works, you would see kind of like, okay, it's been deployed. So everything is live. And you see this URL. So as I said, so you see then, okay, this service is online now. So you can access it with actually this address. So this URL, this is where you would find your app that you have created before. So yeah. And then you can say to Cursor AI, okay, great, I have deployed it now on render. So my script is actually in the internet, my service. Now I need the JavaScript in Qualtrics that calls actually this URL. So this backend that in turn calls the generative AI model and so on. So that's what I would prompt then here. It works. Now I need to update my JavaScript that it can call the backend from Qualtrics. And then you would tell it, okay, and this is the URL actually where the service is hosted. And then you would have this additional security layer that the user is not directly interacting via JavaScript and doesn't have access to the API key. And you have also more, I mean, it adds complexity, but you would also eventually get more security, and you would get also more control if you want to track more information about the interaction, about the user, because it's in a Python script and not only in Qualtrics. So you have a bit more of opportunities what you want to track at the end. It's but if you're just using it and want a simple solution, I think it's fine to just use the JavaScript solution. But yeah, in the slides, it's all kind of explained how you would do it with Python. All right, the last thing that I want to introduce you to is RAG. I don't know who has already heard about RAG, or retrieval augmented generation, and has an idea what it is. Yeah, so the thing, it's a solution that has been developed by in Paris by the Facebook research labs, and the problem that LLMs have is that they at some point have, for example, not updated knowledge, because they are trained on all the information that is on the internet, but some events may have happened afterwards, for example, so it's not up to date. It's also prone to hallucinations. So if it doesn't really know, because it's just predicting actually the next word, that is what an LLM is doing. So if it doesn't really know the answer, it's just like coming up with any random stuff. So it's hallucinating it. And sometimes it doesn't have really access to specialized knowledge. So for example, as a company, when you have very specific information about your return policy or any other things that are not automatically out there in the World Wide Web that an LLM has been trained on, or for us as researchers or teachers, it might be teaching content, for example, that an LLM hopefully hasn't been trained on, but maybe for some reasons you want to give it access that it knows about this content. And another thing is you don't always have transparency. I mean, there are some models like Perplexity, for example, that gives you the sources and the references of the information. So when you look, for example, for recent information, it gives you the source, but ChatGPT usually is not doing that. So when you're asking, for example, for some knowledge questions, I don't know, for example, about how many people live in Oslo, it's not necessarily giving you the reference for that. Or when we do research, I mean, very often when we ask something, it may be very important for us to know the original source. And that's a limitation that you have with the classical LLMs. Here's an example. So an example that the knowledge that the system has been trained on is not always up to date. So here, for example, a user is asking for which club does Lionel Messi play? And then you see here also how the call would look like. So it's very similar to what we did before with the API call. So here you have the system and this the system prompt telling the AI how to behave. In this case, it's not Shakespeare, but it's telling like answer the following question the best as you can. And then you see what the user was asking. So for which club does Lionel Messi play? And here you can see, as of my latest update in 2021, so it's a very old model, Lionel Messi plays for Paris Saint-Germain. For people who follow soccer, they know, okay, this is not up to date anymore, so he's not playing there anymore. This is kind of like a limitation that you have. And but how do we update this model now that it has access to the most recent information? And that's where actually RAG technique comes into play. The main idea behind RAG is that before the prompt is sent to the LLM to create an answer, it's reaching out to a database where you have the specific documents stored, whether that is, for example, specific information from your company about the return policies or your teaching material, or, for example, newspaper articles about Lionel Messi transfer to a US soccer club, for example. So they are stored in a database. And then the idea, what the RAG is doing, is that you ask the question, and the question is going to a so-called retriever. And the retriever is then going to the database where your information is stored. And it looks, when you ask, for example, where is Lionel Messi playing now, it looks for information that is similar, that fits to this request. And it's actually combining the question that you're asking, so the prompt, with the information that it gets from this database. And then this entire package is sent to the large language model to create the knowledge. So in fact, you already give kind of like the answer a little bit in the prompt to create then the better answer from with the LLM. So this is kind of like the simple version, how it looks like.
So what does it use? Does it use like a Google search and then just goes on internet, or?
No, it doesn't go to the internet. It goes to your database that you need to set up. That's something that I would explain on the next slides. It's using, and that's actually where the complexity also comes in. You need to have more, how to say, different models as well. So you don't own, you need more than only an LLM. So you need, for example, a retriever that kind of like encodes your question into what the meaning of your question is. You would also need an embedding model that kind of like also encrypts or saves the meaning of the data that you store. So you need actually different components that I will explain on the follow-up slides, but it's not going online to search for information, for example, with Google. You could also include that it's doing an external search. But what you want to have with RAG is that it's only using the information that you provide in your database, because you really want to make sure, for example, when you create a chatbot for a company, that it's really using this information that you provide in your database and not from any other Google website, for example. So this is kind of like the simple logic behind it. And if you want to set up such a system, the first thing that you need to do is that you need to create actually this database. So you need to kind of like feed all the documents into this external knowledge base. And then, this is kind of like the developer part that we have to do on the first step. And then when the user is actually prompting or searching something, before it goes to the LLM, it's sending the search query to the database and looking for what's, for example, when we stick with this Lionel Messi example, what information do I have in this database that we have set up before that could answer this question. And then it's giving this information that it found there back here to like the system, to the rack that you set up, combining that with this question and then sending that to the LLM, whatever you use here in the background. It can be ChatGPT, it can be Gemini, it can be Llama. And then this answer is sent back to the user.
So the search query is you have to program that yourself, that if a certain question is asked, it is looking in a certain way in the database, right?
Exactly.
It can be just numbers, text, whatever.
Yeah, exactly. So there are different models also that you can implement and different logics that you can implement and use in this entire RAG system. Very often now it's a hybrid system. So it's either using direct keyword matching, which is a rather simple logic. So when you look for Lionel Messi and it finds Lionel Messi, it's just like giving you this context there. The more sophisticated one is looking for semantic similarity. So, and that's why you need so-called vector embeddings, because it's looking actually for similarities in the meaning. So, for example, I set up a teaching assistant for my e-commerce class, and I wanted that students can actually interact or ask questions about my e-commerce content. And so I was setting up this rack with the teaching material of my e-commerce class. And if I would only use keyword matching, and I write e-commerce, for example, with /commerce, and a user would input electronic commerce or something like that, the keyword matching, the rather simple solution would not work. So it's more looking for like semantic similarities. And that is, another, like a machine learning approach to put text into space actually, and to see where is similarity between meanings. And I will show you later how that can be visualized, because it's quite complex to imagine actually how that works. But this is the basic logic what you would need to do. And as a developer, if you want to set it up, at the beginning we have to really deal with the document vectorization, and that is quite already sophisticated part. But this is how it would look like if you set it up. So the user would ask the question, and then you have the same part again, answer the following question the best you can. That was just for the normal model without RAG. And then, it got this information here from the database. Lionel Messi had signed with Inter Miami, blah, blah, blah. The club has announced and so on. So basically kind of like the background information. And then the LLM response would be Lionel Messi plays for Inter Miami CF. Yeah. A bit more, like what's going on under the hood, because I think it's also interesting to understand how this semantic similarity search works. So here, how to set up actually such a database if we want to, for example, develop a teaching assistant at some point. So the first part is that you need to load all your documents into the RAG system. You can save it, for example, in a server, in a folder, and then the RAG system has access to the folder, and it needs to kind of like load with a script, load these documents and then process it. You can already see it depends also on, for example, when we would set up a teaching assistant, that can be PDFs, it can be PowerPoints, it can be Word. So that makes it already quite complex how to deal with all these different kind of documents, especially like Excel is, because there's not really like text. That is quite a challenge. You need at the very beginning an opportunity to load all the documents into this RAG system. And then the first step that would be done for setting up this database is that you split the documents into smaller chunks or smaller parts. And this is already a critical point where you can decide how it should split it, how big the chunks could be, for example. I will show you an example how that could look like. but it's not taking an entire PDF to process it, but it takes parts of it. And you need to decide how big the parts are. When it's done that, when it's split it, all this content, it's doing these embeddings. So that's like putting the text, transforming it into, first of all, into quantitative number or into numbers, because that's actually what machines are working with. And that's also what a usual normal LLM is doing. So in fact, it's not predicting, I mean, it's predicting a next word, but before it's doing that, it's encoding your text into numbers and then predicting the next number. And this number represents a specific word, and that is then displayed. And that is also done here with the embedding. So the text is transformed into numbers that represent different dimensions. And I will show you later how these dimensions could look like. And then these dimensions, so these numbers, for us humans, completely cryptical numbers, are then saved in this so-called vector database that the retriever would reach out to find the content that is relevant for your request.
Did you say letter database or vector database?
Vector, because you would put it into vectors that so that the text is kind of like represented in a space. You will see it in 2 slides, I think, how that looks like. So this is first a visualization of the chunking and the splitting. So which is kind of like this second step. After loading the documents, you would need to split it. And you can go, for example, if you want to play around yourself, you can go to here, chunk width up railway app. And the nice guy, he has set up this this online app to play around a little bit. Here's an input text, just an example, and you would use a character splitter. There are different ways of splitting text, by word, by sentence, sometimes also by meaning. This is already a more sophisticated one, but the simple one, you would just do a character splitting. And then you would decide how many characters actually go into one piece. So here you say 25. So this should be 25. If you increase the chunk size, you see that, you know, the chunks are getting bigger and bigger. So this is actually the pieces that are transformed then into the numbers that are saved into the vector database. So as a developer, you would need to play around with that. What is the best setup for your RAG system? Sometimes it's working better probably with smaller chunks. Sometimes it's better with bigger chunks. That depends probably also on the context of your RAG, but that is then already very technical. Just one thing also is that you can decide the chunk overlap. So here you see that the overlap is, for example, 3. So which means that when you decide for 3, this part, EAN, goes into this part, and into this chunk, and into this chunk. Sometimes that has advantages, because it kind of like makes a connection between the different chunks that you have. Here, EAN is not meaningful, but when you have a bigger overlap and you have, for example, text describing the capital of Norway is Oslo, which is located in blah, blah, blah. And you would chunk after a couple of letters the capital of Norway and then cut off is Oslo, blah, blah, blah. Then you lose some context in the chunk. So you would then have the first one, the capital of Norway, and then the next one is Oslo, blah, blah, but it doesn't know that it's related to capital. So, and that's why it makes sense to have an overlap there, because then, the chunks have connection and you have better performance. And this is how, so when you chunk it or when you split it, the next step would be to embed it. So kind of like to transform it into numbers. that you would put into space to find the similarities between the different chunks. And I think a nice visualization of that is here in TensorFlow. So you can play around with it as well. And I think it's then a bit easier to understand what actually embeddings look like, because otherwise it's very abstract to understand it. So you can go there. And here you have words. And the closer the words, the more similar they are in terms of the meaning. So this has been already embedded. So these are, individual word embeddings. What you would do is like you would embed chunks, so bigger sizes, not only words. But what you can do, and I think that's really interesting, you can also scroll in, and then you can see all the words that have been embedded there. And then you can see, for example, that include is very close to, I don't know, refers, unlike, such, and more different to examples, for example, or to are or whatever. And this has been done also already with the machine learning model, which needs to kind of like understand the similarity between in the meaning of words or chunks, actually, what we are doing. And then because they are represented by numbers in the space, because you would really put them onto dimensions and really have them represented in this multi-dimensional space. So this is how it looks like. And then then we have actually, and we would save these embeddings in our vector database. And then what we would do, we have set up our vector database, then we can actually really use our RAG model, and we can go ahead, and the question that the user puts in, two different things are mainly happening in the same part. So, well, first of all, it's going to the retrieve part. So it's the retriever that is encoding. So it's also kind of like vectorizing your requests. So when you're saying, I don't know, Lionel Messi, it's putting that. It's also encoding that into numbers that are also anywhere there in the space, and then it looks for information that is very close in this multi-dimensional space. And the information that it gets from there, it's putting into the prompt, and then combines that information in the prompt, and then this prompt, what we said before, what we saw before, is given into the LLM, and that one is then creating the answer. So here's another example of how the retriever, would look like. So it would also, you have a question that you ask, for example, when were the Normans in Normandy? And it would encode it, put it into the space, and then it's locating that anywhere in this multidimensional space, and it's figuring out here this information that was in the database, so that the Normans were the people who in the 10th to 11th century gave their name to the Normandy. And then this one is very similar. This one would be then retrieved from the database and included in the prompt that is then given to the LLM. Here another example, how many outputs are expected for each input in a function problem. So this question is obviously quite far here from context A, but it's very close to here this information in the database. So then this would be kind of like retrieved from the database, put into the prompt that is then sent entirely to the LLM. This is kind of like what's happening under the hood. What you can use actually is anything LLM. I think you have maybe downloaded it or used or installed it already. Here's another example of that. That what you can do in anything LLM, you can choose as a user the different LLM models that you have. So Gemini, you can also use Llama and so on. Here I use Gemini, and I also asked the question, there has been a recent major information leak scandal involving Signal breaching its own encryption or servers. The question that I asked, can you tell me something about a recent information leak scandal on Signal? And because even the latest models like Gemini had a cutoff date in, I think, end of, I don't know, maybe in February or whatever. So they don't know about this scandal. So the answer that I got, there was, I don't know about a major information leak scandal involving Signal. There was something in August 22, but I'm not sure if you're looking for that. So in fact, it doesn't have this information. So what you can do then on anything LLM, we can do that together. Need some time to load. Okay, here we are. I have set up already, I don't know how I can delete it. But you can create a new workspace. I don't know if your screen looks similar or if you are really at the very beginning where you have to set up what model you want to use. So, okay, you're waiting. Yeah, it takes some time. What you can do, you can select, and that's the advantage also of anything LLM, also like a dealer where you can choose the different LLMs that you want to use. You can use, for example, Gemini, and then what it will ask you is for the API key. So then you interact with Gemini through anything LLM, and the API key kind of like allows you to access Gemini Gemini AI.
So in that case, do you then choose to use anything LLM or you choose to use Gemini?
Yeah, so in fact, anything LLM is a bit like this program what we saw yesterday, Poe, where you can also then change between the different LLMs. Sometimes one program is a bit better than the other one. So that is one advantage of anything LLM. And the other one is that you can set up your own RAG system, which I will show you. And that's why you would kind of like use the model that you choose. So now you can choose, for example, Gemini, and then you would use Gemini through anything LLM, which has advantages because you are more flexible and you can change between models and so on. So class Oslo, for example, I would just set up my workspace. And then I could ask this question again. I don't know if you are in a workspace already.
You have a suggestion for which version of Gemini?
I think you can just try the latest one, 2.5. I think that's the best. Because even these latest models, they are not aware of like the latest incidents.
You explain these embedded llama and
Yeah, so it's using what we said before. For the RAG, you need, for example, an embedding system. So it's a machine learning system that transforms your text into these vectors. And by default, anything LLM proposes you some machine learning models. And that might be, for example, Llama, or you can change it later on. But anything LLM has a default using the ones that you see on the screen. You can just accept it. Yeah, that's fine. Yeah. So, and if I ask this question again, was there a recent signal incident with the Trump administration? Usually it should not be aware of that, and then it cannot answer that correctly. So yeah, I mean, there were many incidents with the Trump administration, but not the one that I was referring to. So there was one 2021. So if you want to make update it with the knowledge, and that could be then, for example, that you want to update it with the latest, I mean, because we don't want to talk all the time about Donald Trump, it might be also for research papers that you want that it's aware of, that you can talk about it, about research papers, for example. Then you can actually go here to this upload button. I have already some in here and I will delete them. And you can feed the documents into the system. So you would here either click to upload or drag and drop. And I have prepared already here documents for RAG example. I have just downloaded last week some PDFs, talking about this recent incident with the signal scandal and so on. So we could use these examples that I just downloaded and upload that into our anything LLM. So either just by drag and drop here, that should work. So it's uploading these documents. Then you have them here as uploaded on my documents. And then what you need to do is you need to mark them, and then you need to move them to the workspace actually. So you have them down here in the workspace. So for the one that we just set up, class Oslo, for example, and then save and embed. And then it's actually running this machine learning model in the background, this embedding system, and then you can change it in the system, which one you want to use, because there are different machine learning models for that. But as I said, so anything LLM has a default model that it's using, and I think that's also quite okay. And then you do save and embed. And now it's in the background, it's kind of like chunking all these information from the PDFs that you just fed into the system, and it's putting them into this multidimensional space. And of course, dependent on how many models, how many documents you're feeding into the system, that may take more or less time. So when you feed all the documents that you have into it, it may take some time. So, but now it should be fine. So they are all processed and you have them in the workspace. And if you would ask the same question again, was there a recent signal incident with the Trump administration? It should answer correctly. Yeah, so now it's telling you, yes, based on the provided context, there was a recent incident involving Trump and the Signal app. Top administration officials, including Defense Secretary Pete Hegseth and National Michael Waltz, use Signal group chat to discuss upcoming military strikes and so on. So, and this is just an example, but of course you can use it then also to feed the system with relevant journal articles, with any other relevant information for you, and you can make sure that you can update, or that you have an LLM that has really access to accurate information when you want to chat about it with, for example, journal articles or something. Just to finish, so this is how you would set up a RAG system for yourself. If you want, for example, to create a RAG for others because you are, I don't know, a teacher, and you want to set up a teaching assistant that is accessing your course material, and then you would give this teaching assistant to your students. I mean, of course, you want to make sure that the content is really accurate, that the students getting information about. You can use different services online because they facilitate the connection of all these different machine learning models, so of the retriever, of the embedder, of the LLMs, and so on. So it makes it a bit easier. One is called, for example, LangChain, and the one that I recently thought is quite quite easy to use, but still quite difficult. Or because, I mean, it's getting then quite technical, is called Haystack. And there you can see that you would use this service, and then they offer connection to many other services that are offering the vector database, for example. So these are examples for vector databases like Pinecone, Cone, and so on. And kind of like these services facilitate the setup of RAG. Because what you have now is with anything LLM is that you can interact with it yourself, but you cannot give it, for example, to students to interact with that. And if you want to set it, because at some point you would again need to deploy it online, you need to host it on a server with a URL that you can access it in the internet. And for that one, you would need then some services like Haystack or LangChain. And then, yeah, you would need to build your own RAG.
We uploaded now a few documents. I just did some academic
Mhm.
articles. Are they now just uploaded into a different area on my computer, or is it now on the in some server with anything LLM?
Good.
Local.
It's local.
Yeah. Now, if you save it you download the desktop version, and then you save it in your local.
It's still local.
Yeah. And the problem is if you change computer, it will be difficult to bring that database you created with you. So my solution is that I use Docker and then package it together. And then if I change computer, I can always bring it together with me. So there's several different options.
Can I link it to, let's say, a Dropbox Surf Drive folder or like iCloud, and then like do
I think you can check. I'm not sure.
That it's automatically updated. That would be great. Yeah. If it's, I don't know.
Or
If
maybe
not,
you can install your app in the Dropbox. If it's possible. I use Docker, so my Docker, the whole thing is in the Dropbox. So if I change even I change computer, it doesn't matter. I just use the Docker to open the other file again. So it's like you compress the app into a file. So you can bring that file everywhere with you.
If you compare to Notebook LM, what would you prefer?
Notebook LM only support up to 20 PDF. But this I can upload everything I read. So now my record is like 1,000 PDF, something like that. So really all the PDF I read, I put it there, and then I can just use the chat function. If I forgot a scale or a certain concept, it can always help me to read it back.
Do you create subfolders in order to put these?
So you have different workplace, right? In this case, you can have different.
So like you did with projects on local.
Yeah, but mine is just now I put everything there. I don't care because for different project I use Notebook LM. But now it's just everything I read, I put it there. So I don't care about different projects. So if I forget anything, I just ask it there.
Do you like a separate in different workspace, or you just?
No, I did not at this moment.
Okay.
Because all my it's mostly academic papers. So and yeah.
great. Do you have any questions about the content with RAG, or also about the content with how to connect Qualtrics to the LLM? I'm also happy to help you individually afterwards if there were some issues, also how to use Cursor AI. I think with anything LLM, Shubin is a bit more experienced with Cursor AI. I can help definitely. Yeah, so otherwise, I think it's time for a break, right?
Oh yeah, we have finished. So our morning section will stop now, and then we can have lunch. And the afternoon section will start at 1:30, where I first will talk about some advanced topic like how to fine-tune your own model. For example, this is one way but if you really want to train a model that can help you to write a manuscript according to a certain journal style, then you need to train the model, right? So in this case, you need to fine-tune the model. So that's what we are going to cover this afternoon. And also, we will also have another speaker talking about synthetic data. Yeah, so C-Hay will come later and then talk about how to create synthetic data. And then we also have 2 exercises that we can do together. And if you submit one of the exercise, then you will get a certificate.
Nice.
Also for the online audience. Okay.
Okay.
Thanks.
Thank you.